Okay, so this is the second of the optional videos that deals with the proof of a theory we're going to use. So lesson 7 is all about the area of a triangle, and we're going to be using this formula that's written in the center here, area equals half AB sine C. So in the lesson that you're required to do, I'll just be talking about how to apply that. I won't be talking about why it is that that exists. So this is an optional video for those of you that want to know why. So if we go right down to the bottom here on OneNote, I've got a little proof section set up. So much like the other example, we just start with a triangle ABC. And of course, that means that this side here can be represented as a little a. This side at the bottom here can be represented as little b because it's opposite angle B. And this is little c because it's opposite angle C. And very similar to the sine rule, we're going to start by just saying, well, if we want to know the area of a triangle, we need the base times the height. And the height we'd usually get by getting a perpendicular line up to the top of our triangle. So we've got ourselves a perpendicular line. Well, what if we can use trigonometry to represent that perpendicular line's distance? Then maybe we can work out the area of a triangle without needing the perpendicular height at any given time. So in this particular case, we're going to look at this right-hand triangle. We're going to look at the right-hand triangle on this side, this little right-angled triangle there, and see how we'd find, and we'll give this this spot here a name. We'll give that D. So this length here, the height, is going to be BD. So can we determine what BD is using trigonometry? So in this particular case, if I'm thinking of this angle in here, angle C, and I was using, I know I've got to use sine because that's in the formula, but let's just use that anyway. So we've got the sine of theta is going to be the opposite over the hypotenuse. And in this case, theta is C, so we're going to say sine C equals the opposite to C is that angle B, is that side BD, which is our height. That's the bit we want to know. And A is the hypotenuse of that particular triangle. So if we multiply both sides here by A, we're going to end up with A sine C equals BD, but BD is just the height of the full triangle. So if we think about this, let's just go, and I'll switch a colour pen here. So if we think about what the area of a triangle is, well, it's just half base times height. Now, the half's not going to change. The base of this triangle up here, well, that's B, strangely enough, which is going to be a bit confusing because there it means base, here it means side B. We'll just have to deal with that. And the height, well, we already know the height here we just worked out was A sine C. And you can see here that we've just rearranged it so that it's in alphabetical order. If we just rearrange this, that's going to be half AB sine C, which is our formula for the area of a triangle using trigonometry. So that's how that formula has come up with. We just do it by creating a height that we don't know anything about, but using trigonometry to find out what we do know about it from the triangle that we have. So in this particular case, as long as we have two sides and their included angle, so A and B and their included angle, we can find the area of any triangle. And that's the end of this proof.